Question number 7 is a complex number transformation sum, and it's very easy, but it might not appear to be so because of a trick they have used. They have used the alphabet Z and the alphabet W. You have to understand this is not a W plane or a Z plane sum. They just named the complex number W. That's all. It's like this. Suppose someone says, "My right hand man." Now, the right hand man doesn't mean it has to be a man standing on the right hand side of a person. A right hand man actually means a very important person or a very important assistant or a very important, helper for someone. So if a right hand man can be a woman and the right hand man can be standing on the left hand side, that doesn't mean, it just means a very important person to someone. So that's what it is. Now the complex number is, z equals to x plus iy. Now they usually give different complex number by the symbol z1, z2, like that. But here what they're doing, they're calling one complex number z and the other complex number w. So both the complex number are in the, the regular complex number. There is no w plane over here. Both are Argand diagram, Argand diagram. There is no w plane or x plane. So that is the trick. It might not appear to be so. Now the first one, as you remember, the transformation that has, z minus a1 plus I b1 equals to lambda z minus a2 plus I b2. That is a circle. That's what it is. That's what the first one is. But again, it doesn't appear to be so because there is no number over here. But if you pay attention, you would see actually there is, because if I take this side and if the z coefficient has to be free, if I take this 2 common, it becomes z minus half, and if I put the modulus, it becomes, so modulus of 2, and it becomes modulus of z minus half. So modulus of 2 is 2, so it is basically absolute value of z plus 1 equals to 2 z minus half. So this is a circle, but it doesn't appear to be so, but the constant is multiplied with it. So let's start doing the sum. So the first transformation is going to be, so z plus 1, that means z minus 1 plus 0i, that is the complex number. So equals to, if we take this 2 outside, so it is going to be z minus half. So when modulus is multiplied, it's the same as modulus of 2 multiplied by modulus of z minus half, means z minus half plus 0i. This is what it's going to be. So this is going to be, z minus 1 plus 0i. Modulus of 2 is 2, and this is going to be z minus half plus 0i. Of course, I could have just directly put the value of x, z equals x plus iy. That would have not made any difference at all. I'm just expressing the format. So this is going to be x plus iy plus 1 equals to 2 x plus iy minus half. And if you do the algebra, this is going to be the real part, x plus 1 plus iy. This is going to be the imaginary part. So this is going to be x minus half. This is the real part, plus iy. This is the imaginary part. So modulus of this is going to be square root of real part whole square plus imaginary part whole square. This is going to be 2. Again, this is going to be square root of real part whole square plus imaginary part whole square. So doing the algebra turns out to be x squared plus 2x plus 1 plus y squared. If we send the square root to the other side, this is going to be whole squared. So this will be 2 squared, and this square root will disappear. This is going to be x squared minus 2ab is going to be x plus 1 by 4, and this is going to be plus y squared, and the whole thing is multiplied by 2 squared, which is 4. This is going to be x squared plus twice x plus 1 plus y squared equals to 4x squared minus 4x plus 1 plus 4y squared. If we bring all the x squared and the y squared on the other side, this turns out to be 0 equals to 4x squared minus x squared plus 4y squared minus y squared. Then this is going to be minus 4x minus 2x is minus 6x, and this is going to be minus 1 plus 1 is going to be 0. So plus 1 minus 1. So this thing cancels off, and we get 3x squared plus 3y squared minus 6x equals to 0. So this is a circle, and we know the center is going to be If first of all we have to divide by 3, so this is going to be x squared plus y squared minus 2x equals to 0. So we don't need the center actually. We just need to, find the equation. So let's move on. So the next transformation is w modulus equals to modulus of w minus 1 and plus I. So this is not a w plane. It's just a complex number called w. That's it. So for modulus of w equals to w minus 1 plus I. Remember, this was the first format. So there was a lambda. So this was a circle for sure. But this one doesn't have any lambda over here. That means it's a perpendicular bisector line. It will be a line. So let's do this directly. So this is going to be, instead of w, we can again write x plus iy because it's the same plane, same z plane. This is going to be again x plus iy minus 1 plus I. So this is going to be square root of, the real part is x squared plus y squared. This is going to be square root of, the real part is x minus 1. So let me write this down. X minus 1 is the real part, and if we take the I common, it will be y plus 1 I. So that's how it's going to be. So this is going to be x minus 1 whole square plus y plus 1 whole square. So if you break this down, it is going to be x squared plus y squared equals to, if we do the whole square, the square root to this side, this square root will disappear. This will be x squared minus 2x plus 1, y squared plus 2y plus 1. So this is going to be, this x squared and this x squared cancels off, y squared and y squared cancels off. We divide both sides with 2, it's x equals to y plus 1. So therefore y equals to x minus 1. So we found two equations. The first one is this one and the second one is this one. Now we have to find the point of intersection. Find the exact coordinates of the point of intersection of the locus of P and the locus of Q. Remember, it's still in the z plane. So to solve this simultaneously, we can write, so putting y equals to x minus 1, it becomes x squared plus x minus 1 whole squared minus 2x equals to 0. So this is x squared plus x squared minus 2x plus 1 minus 2x equals to 0. This is going to be 2x squared minus 4x plus 1 equals to 0. This doesn't go middle term break, so we can solve this by quadratic formula. So minus b plus minus root over b squared minus 4ac divided by twice a. So this will be 4 plus minus root over minus 4 squared is 16. 16 minus 8 is 8 divided by 4. So this turns out to be 4 plus minus 4 by 4, and square root of 8 is 2 squared root 2 divided by 4. This will be 1 plus minus half square root of 2. So the y coordinate is going to be, so when x equals to 1 plus half square root of 2, y equals to 1 plus half square root of 2, meaning x, minus 1. So 1 minus 1 cancels off. It will be half square root of 2. So the first point is 1 plus half square root of 2 comma half square root of 2, and the second one is going to be when x equals to 1 minus half square root of 2, y equals to 1 minus half square root of 2 minus 1. So 1 minus 1 cancels off. This is going to be minus half square root of 2. So the point is going to be 1 minus half square root of 2 minus half square root of 2. So we found the 2 points where the two pictures intersect. So let me just repeat, this is not in the w plane or z plane. It is just they're naming the complex number differently, z and w. It's like an optical illusion. When you do the sum, you suddenly think it is going to be another plane, but it is not. It is just z1 and z2, and it is all in the xy plane.